All right, hello everyone, and welcome to another XAFer community stand-up. Today we have a really exciting topic. I think you guys uh, will really enjoy what we have prepared, but basically is a way to run, as we call it, a thin client in XAF, basically allowing us to scale more, allowing us to do really neat things. So, as always, thank you for coming. I see a couple members that are always here with us, so thank you everyone for joining us. And Hocha, let's go straight to the point. Feel free to share the
Yeah.
screen and let's start discussing what we have.
Okay. So let's see. I was taking a picture for the memories. Okay. So today we have a really exciting topic. What we're going to show is what Javier said, that is something like it's a thin client for XAF. So let me start sharing the screen. So we'll go directly to to the example. So today what we're going to show you is basically a thin client for SAF. So we have developed like a small template because we have used this several times to do some type of migration or load balancing or so on. So we kind of have the base project, and then eventually we do the modifications to match the UI of the customer and so on and so forth. But a lot of the basic functionality of SAF is already working in this client. So a few things that I want to show you. Let's first start with, okay, this is how it looks
Yeah,
like.
the first thing
Mhm.
Hocha want to say is that what we're seeing here is not XAF, it's just Blazor. So, but if you see, it looks like XAF. We keep the same look and feel. We have the same, uh, basically, editors, the same list view. So everything stays the same. We try to reuse everything we have in XAF and basically mirror it here.
Yeah,
Yeah,
so
continue.
that was one of the ideas, right? Like first, maybe you don't want to change what it is. It's like you have a lot of development done already, and then you're just looking for a way to make it lighter and to make it maybe match your infrastructure so you can scale it later. But I will talk about that a little bit later. But as Javier said, like this is not a SAF application. This kind of look like a SAF application. Well, I have only one monitor today, so some things I cannot remove from the screen. Um, so we wanted to go with that look and feel, right? So here, what you see is kind of the welcome screen where we have track of what we have implemented already and what is still missing. So things that we have that are really nice are the UI generation by metadata. This means that whatever you have done in SAF, it will kind of look the same in here. Of course, we have not done it like 100% because we don't need it to do 100%. In most cases, you might want to do some redrawing of the screen or so on. So we have the UI generation and it's working fine as just as we wanted. If we need to improve it, we will improve it later. But just to show it how this looks like, for example, we can go to this invoices example screen. This is a split screen. We have the list view and we have master detail. So here we have the records on the side and the list on in the middle. So it works exactly like an XAF application. We have the action area, and then we have this type of debug information. Here we can see the metadata of the entity of the list view, like which entity it is, which caption it has, the sorting, the page size, and so on. A lot of things that are settings that come from SAF that we can figure out from SAF. We automatically do it here. Like, I mean, we execute it here. Also, you can see the appearance rules for this entity. So when the status is overdue, it will be in red. When it's paid, it will be in green, and when it's canceled, some of the things will be read only, like they will not be enabled. And these things I cannot actually write when it's canceled. And then if we have active filter or so on, this is like we don't have too many information from this view right now, but this is the automatic view generation that I was talking about also. Let's go to customer here. Let's open this customer. So if you see this view look almost the same as a SAF view, I've been playing around with this demo for a little bit, so maybe it's a little bit messy, but in general, you get the point, right? So um, you have all the normal property editors for date, for this is like a status, for example. And we even have a small version of the customized layout. So we can move controls, make them a little bit bigger, or so on. So we even have the layout customization part. I mean, we're moving the parts that we think that are most important from basically the validation rule security system and UI generation being the most important, and then the other things we are like depending on the customer. So this is like a kind of a base project. So then we get the captions from SAF, we get the captions for the columns on the list view and for the detailed view. So if you have done that already on SAF side, it will reflect in here. Another thing that I want to highlight is that this application has zero direct reference to SAF, which means that there is no SAF DLLs, nuggets, or assemblies on this project. It basically everything I mean, we get it from the API. There's no direct reference from one project to the other. So let's add a customer here to show this. Let's add new customer. This will be Sari, email, info, phone. So this one. And this will be active. So we can save. And it's done. We can add customers now if we want, but I wanted to show you in the list. So here we have Sari. So as you can see, the CRUD operations, they do work exactly as the same. And then we have here, we can do some filters. This is a single choice action. So we can even port the controllers and the single choice action, simple action and pop-up. All of those things have an equivalent on this side. So we can do the CRUDs, we can have the controllers and the actions, we have the same construction of the UI, we have the blend information. So far to be a project that is apart from SAF, we already have a lot of SAF functionality on this side. Let's go back to the dashboard. So in here you see the entities that we have, which role we are logging in at the moment, and which navigation item we have access, plus the metadata that we have obtained from SAF, the validation rules and the conditional appearance and all the rules here. So this helps us like as an overview of, okay, we have ported this and we can use this information. Well, then we have some other things that I will talk about later. I guess you see already something, I mean, some part of the of what we wanted to show you regarding the UI. So let's talk about what it is that we have here. So this is a small presentation. So basically, this is kind of an evolution of how we have been developed. We do SAF applications, and we usually use SAF applications as backend for mobile applications. Actually, we do a lot of mobile applications lately. So that's where the idea came from, right? So we have so much good information from the SAF side that we can just extract that information and make another type of head project. This can be a MAUI project. Javier already showed something like that before, like, okay, we have this MAUI application connected to XAF. So what we have so far is, well, we have the head projects from SAP, right? We have the Windows Forms, the Blazor, the Web API, and then we have this one that we call Singular for the moment. It's just a code name. This is active development, so we wanted to show this. So before also we had web forms here in the middle, but we removed it from the presentation because we are not using that anymore. So basically you have three head projects, Blazor, Windows, and Web API. And now this type of project that we have added. This is what we were talking about before, that SAF provides a lot of metadata. For example, the conditional appearance, the validation rules. And this is one of the parts that I love the most about SAF is that it gives us, well, this will sound funny, but a framework to do things, right? So for example, I know that if someone wants to change how the UI looks, like changing a field to red if it's below zero, uh, I know that people will do a conditional appearance rule. So I know that everyone in my team will do the same. So I know where to look for these things, right? So this is one of the things that I love about SAF, that it unifies how we develop software and how we understand each other between I mean, our company or other programmers and the group that we have. So the metadata pipeline is one of the most amazing things from SAF. So we have the attributes, that is the compile and the code model. Then we have the application model, that's the one you edit with the model editor. And then you have the web API and the live UI, that is what we're showing right now. So this gives us like this type of architecture. So we have the web API, which is one type of head project actually. Then we have the Windows and Blazor application on the side. And then we have the pure backend, which is where the data is stored, which is XPO and Entity Framework Core. Like it can be any, I mean, the metadata is the same. It doesn't matter which application it is. If it's Windows Forms, if it's Web Forms, if it's like Blazor, or if it's XPO or Entity Framework, it doesn't matter. I mean, we expose the same metadata through SAF. And then we have the other possible projects that we can have, which are like a, a Blazor application totally disconnected from XAF, or a MAUI application in this case. So these are the features that we are reusing from XAF. And what we reuse and what we think is the most useful parts are the security system, the navigation and permission, the validation rules, and the conditional appearance. There are other parts that I didn't include in here because this presentation maybe is not completely updated. And was one of the first parts that we did was a way to project the controllers, the simple actions, single choice actions, and pop-up actions. There is a way to basically render this on the client side in this new thin client that we have developed. So you don't have to rewrite that. You can basically reuse like 90% of XAF in this thin client, even having no reference to SAF directly. So it's kind of a really neat thing. Um, and then also what we have here is like, once we have the web API as backend, we can do other type of arrangements in our infrastructure. For example, web APIs are usually stateless, which don't save states, or like there is no session, there is no variable keeping like the status of the system. You just do a stateless request. It's like you send the request, you get the values, and that's it. There is no state keeping on the server side. So that means that you can put several API nodes like shown in here. You can put 20, 50, like 100, two, depending on your need, right? And then you can put a load balancer in the middle. And then in front, you have our own thin client. I will do a demonstration of this a little bit later. So the idea is here that our client do the request to the load balancer. In the case that we have here in the office, we're using YARP, which is yet another reverse proxy um, project. So it's like basically a load balancer. You have many choices there. You can have Nginx, you can have HA proxy, which is from something from Linux. You can have Apache, like all of the web servers, even IIS can do load balancing. Like you decide how to split the request. The usually the best case is either geographically or round robin. Uh, for example, you can say like, okay, if this customer is from Europe, I will forward it to the servers in Europe. And if this customer is from America, I will forward this to the servers from America. So it resolves faster. So that's the idea of the load balancer, right? So, and also you split the load. For example, this is something that we talk a lot, but I think that is kind of a misunderstood um, part of the system. So once you have a load balancer, what you want to check is these numbers, the P50, P95, and P99. And these, they do have some specific meaning. And the meaning is, okay, for example, the P99, it means that 99% of my requests are under this average time. For example, you want to say, I want that 99% of my requests are under, I don't know, 500 milliseconds. That's half a second basically. So you can establish, okay, like I know that this entity is really big. For example, if you do customers and you have 2 million customers, that request maybe will be outside of the 500 milliseconds, maybe will be 10 seconds because it's a pretty big entity. But you need to try to work on these numbers, okay? Like 50% of my requests are under this time, 95% of my requests are under this time. So that's how you measure that. Once you have a load balancer, you need to keep track of these three magic numbers and the average to see, okay, like most of my requests are done between uh, 0 milliseconds and 900 milliseconds, something like that. And also, once we have this type of schema, like once this type of setup, I mean, regarding infrastructure, you can do other things. There are many ways to do load balancing and caching. Um, you can do them at the database level, at the data store level, at the object space level. You can do it at the URL level, which is one of the most common ones in traditional systems. So, for example, this is what I mean. Uh, if you don't have cache, what will happen is that your application requests this endpoint, and well, the load balancer sends it to the API node, and the API node sends it to Postgres, and this takes 15 milliseconds because you need to get the connection, you need to execute the query, get the data, and so on. Actually, this 15 milliseconds is kind of really short time. This request is fast, but imagine that this request takes 5 seconds. So this is what you will do in other cases. You have the browser, you have the request to the same URL, so you can introduce some type of middle layers that you say like for example, like you can use um, well, there's many ways to handle this on .NET, but you can introduce a middleware that if you say that this is the request, then these values they don't change so much, then I can get them from Redis. So instead of sending it to the database as you did on this side, you send it to Redis or some type of, I don't know, Cassandra or so on, any type of memory database, and then the request will take like less than 1 millisecond. It depends on your case, right? These numbers are just kind of projection, but this is the things that you want to do once you have this type of setup. You can check the list of requests and say, oh, this is slow and this data doesn't change so much. I can programmatically add something so that request is faster. Um, so here you have the same example, right? So one is 12 milliseconds, one is less than 1 millisecond. So this can affect a lot on the system performs because usually we query a lot of what we call in Spanish like master data, um, which is not the transactional data. For example, in an invoice, the transaction is usually the invoice, right? But the customer, the product, and categories and things like that, they almost never change, even though we query them all the time. If you make 100 invoices during the morning, 100 times you query the customer, you query the categories, you query the products, even though they might have not changed at all. So you don't need to query them. So in that sense, you can say, okay, the products I change only once per month. I can catch that in memory in the morning, have them all in memory, and then it will take like less than 1 millisecond instead of, like 5 seconds or 50 seconds or 20 seconds, depending on your design, right? This will mostly depend on you. And well, we can do other type of head projects. We saw that before. Here is the live demo. This is the same demo that we were showing here. It's actually embedded in a frame. So that's really nice for the presentation. But there is one other thing that I wanted to show you, and is, well, one of the things that is really hard and that have been asked a lot regarding SAF is, okay, I want to persist the circuit. The circuit of Blazor is this memory part that keeps track of how the DOM is, how the UI is being rendered, and so on and so forth. So the circuit in SAF is kind of really complex because it has other non-serializable objects inside. For example, XPO is hard to serialize, and it's not an XPO fault. It's like any type of self-reference tree can serialize forever, right? It's like you have too many nodes and the nodes refers to themselves again and so on. Uh, so it means that it can look back and do some type of overflow serializing. So some type of class trees are hard to serialize. So SAF will, I mean, XPO will be in one of those. You don't know where to stop serializing. You can always do, because of the lazy loading, load the navigation item, sorry, load the navigation properties, serialize them. They refer to all the navigation properties, serialize them, and until you serialize all the database, right? So some type of information that SAF keeps on the circuit is really hard to persist because of that situation. And there are some other things that are hard to persist too. So usually what you keep in there is some type of session information on the SAF side. And in most traditional applications, what you keep is some type of the state of the UI. SAF also do that. But in here, since we have no uh, state saved on any part of the application, I mean, we communicate to a stateless API like REST APIs. Um, we don't keep any track of that of the circuit basically. So this will resume in something like this. Imagine that you're filling a form in your application and your form is like 200 fields long. It's like a really big form. We have like five fields here. So for example, here I can write my name and then something happened. The internet went down, the electricity went down, and so whatever reason that you're in mobile and you move and you get disconnected. So in here, I can disconnect the circuit and I'm persisting the state of the circuit somewhere else. So when the circuit comes back, my form stayed the same. So what happened is that here we save in Redis like a key, which is like, okay, this is what we want to save, and then the state of the UI, and then we pull it back. So this is one of the other things that I really neat about this architecture, that we can introduce load balancing, we can import almost everything from SAF. I mean, everything that we want in general. It's just depending on the case of the application that we're migrating from. And the circuit part is something that is been requested many times. And since we did these experiments, we say, okay, let's cover that use case. And well, the last one that I want to show is in our internal tests, we have done like our own load balancer. And this is how it looks like. So here you have, well, if we're in development, we can add API instances, as many API instances as we want. For example, we did a case, okay, like what is the sweet spot between user numbers and instances? So it will depend also on how you design your ORM. That's kind of the most important part here because maybe you have some really deep complicated loading process or so on. So it will increase the time of the request. But um, here in development, you can add as many APIs as you want. And also, there is something I kind of forgot about this. One of the important things here is that we can have a Blazor WebAssembly client. That means that we only host the APIs. We host in some static hosting the application, and um, there is no front end um, processing from our side. It will be everything will be like just backend processing. So to add a Blazor WebAssembly project is kind of a really interesting choice. So let's go back to the load balancer. So here, let's clear all of this. So as you can see, there is no request and there is no instances here. But if I start using the application, let's go to customers. Then you can see that I went to customers here. So see, these are the endpoints that they've been hit. They did one with top 20, then with top 0, then with top 1 and skip. So you can see all the requests that the grid did to load this data and with the specific filter and so on, and how long it took and which type of response it had. It was, this was, all of them were 200. And see, some of them took 4 milliseconds and some of them took 125 milliseconds, depending on what you're doing. So, and we have 4 requests, and you see that we did 2 on each of the nodes that we have. We have 2 processors running the API here. So since this application is communicating with the load balancer, then we have split the 4 requests that we did happen between 2 servers. That improve our time, or requests are faster in general. So if I do more things like opening a customer or opening invoices, I can see all the requests here and how long it took and what was the URL. So this helped me decide, okay, this request was too long. I can cache this. This time was like, it's always slow. So you can figure out what to do. So it's like a really good way to test your performance. Okay, so that's like what's happening. Like the load balancer that we have is tracking everything. So we know which request to pay attention to. So let's clear the data here again. And then we have other thing that we use a lot for this type of projects. So if we go to the, well, we can go here to load test. Let's start with this one. Then this is the amount of, amount of users that I have, or one, and this is the amount of requests. What does this mean? This means that there will be like one HTTP client, and this client will do 200 requests. So let's see how this looks like. So as you can see, the 200 requests were like super fast. This is already done. You can see which points that we touch. We get the metadata, which what we use to construct the UI, the rules, the appearance, and so on. Navigation, then we touch every other endpoint for data. And this database only have like 4 records or 5 records. So it's like, see, the requests are under 1 millisecond each. And as you can see, it was one user, 200 requests. And these requests, they split between 2 servers. So the load, this will have take maybe double amount of time if it was only one server. So here we can see that the load balancing can reduce the time in general. If we want to do 2, then it will be like 200 each. So see, it's always evenly split. We have the number 1 because you have to log in to get the token. So it always, whatever you have here, plus 1. So let's clear all these things here. And the other thing that we can do that this is really useful is related to this other part that I was explaining is, okay, we can record a session. Here I have one recorded already. Let's clear this. So when you record a session, this is keeping track of all the requests that we're having. So if we, well, let's close all of this. And then let's go customers, products, invoices. Then we pick one invoice. Then let's validate this is valid. And then we can do stop recording. And now we have a session. During this session, I was logging as admin. We did 24 requests, and this was the time that it took. And I can see, if I view here, I can see all the requests that we have done with the filters and everything, and if it was success, how much time it took. So I can really easily replay what was happening in the system. And then I can clear data and I can replay this. So basically, that's what we have so far. I think this is a really neat way to handle a SAF application to take advantage of the most things that we have in general and to do this type of experiments that we rarely see on reality. A lot of people talks about load balancing and like how to scale an application. And well, most of them are monoliths. And once you have to load balance an application, it's rarely about which framework are you using to develop your application. It can be XAF, it can be ADF from Oracle or any other thing. Then it moves something between infrastructure and coding, which is kind of a really strange place to be. Um, but what I want to show is that, okay, we have the SAF application, we can generate the UI again, reuse everything that we have. We can introduce load balancing and some other things like the take from the circuit. And all of these are basically coming from the SAF side. So as you can see, you can have whatever SAF bring you out of the box, or you can start developing some other functionality on top of it. So that's what we have so far. I
Yeah,
hope that
right
you
here,
like.
Hochi.
Mhm,
I just want to mention that what I really like about this is that we still keep using XAF as we use it right now. If you want to add a new business model, you add it in your module project. If you want to add a new validation, a new appearance rule, a new controller, you keep using XAF, but you have another head or another client that actually, through
mhm,
the web API, is able to reuse all of those things, make your app faster, more, especially in the one of the things that we are always hurt us a little bit is that session recovery, that you will use something that actually save your whole state of where you at, and you will know that XPO and they are hard to serialize in this way, and we could add this new layer, this new way to containerize load balance, cache, and all those nice things that actually, in theory, make your app infinitely scalable because it's up to you to set a good infrastructure to make it work. But yeah, we're excited. We are adding more and more things, so you will hear more from us. And as always, I'm really excited that you guys join us at least once a month to discuss about what we're doing, what SAF is doing, what the Express is doing. And I will say, this is our own, again, always a little bit of sand that we put on the development of XAF, but we know that the XAF roadmap is made XAF as scalable as possible. So in the future, if they release that version, we'll definitely will be using that one. But in the meantime, I think this gives us a huge push in the way forward, in the right way to do a different client, and opens the collaboration for things like we have talked in the past, Maui, mobile apps. We still use Safari Web API heavily for all of those. Before we go, I want to show one thing really fast, Jose,
mhm.
because we have a video in our channel that you guys can take a look about how it works, but I just want to basically make the point. Let's give it a second, let me know when it loads.
It's
Can you
still
see my
loading.
screen, Hutch?
Not yet.
All right, just let me know.
It's taking forever, to be honest. Maybe you should stop it
Yeah, it's really
and
a
have it let me
little
know.
bit slow. All right, but basically it's just this. I'm not gonna run a demo or anything. Just showing that our static group, a dynamic group client for XAF Web API, is live on Google and on Apple. So you guys can download it, take the swagger of your software API, paste it here on the server configuration, and you will have a dynamic app to do all the CRUD operation on your model in your SAF app. And it has really nice configuration screen where you can actually decide what you will see on the navigation, and even there you can click this arrow, what fields do you want to see, which fields do you want not see, and you will be able to do CRUDs on your XAF app right away. That's basically it on our side. As always, thank everyone who show up. Thanks everyone for joining, and we'll see you next month.
See you.
Stuff up. All right. Sorry. I lost the stop recording. Give me a second. Right here.
Yeah, it happens to me. It happens to me.